Good evening, guys. Welcome, all of you. Okay, please confirm if you can hear me properly. All right, guys, very good evening. So, yes, we are going to continue our discussion on YouTube session. So, guys, as you know, the timing has changed. The usual sessions on Thursday and Friday, right, till October, it was 11:15 a.m., but now it's going to be 9 p.m. Okay, so the YouTube sessions are going to be on 9 p.m. every Thursday and Friday. All right, this is the new timing for the month of November. All right, so yes, let's also discuss, guys, what's going on Unacademy Plus. Let me inform you very quickly कि Unacademy Plus में फिलहाल हो रहा है organic spectroscopy, organic structure determination, right? 7th of November, and it's still going on. We are doing the IR spectroscopy. We have already done the UV visible spectroscopy. Okay, yes, very well. And also, guys, if you are interested in joining Unacademy Plus, these are all the courses that I have taught on Unacademy in this new session, right? So what you can do is, even if you have subscribed to Plus or not, you can just visit my profile, and then if you want, you can just open up the course pages. Open the course page, you will see all the contents. Okay, so you will be able to check what I have taught on Unacademy Plus, right? And yes, if you want to join Unacademy, you can use while you are paying through any of these packages. Okay, all right. Now there's one more thing for all of you, that if you are joining them the test, the Unacademy Plus, now you are going to get the mock test, which are basically your PYQs based mock test, okay, which are going on, and soon your CSIR NET or GATE mock test series is going to start as well. So these are all the topics that I can take a screenshot if you want. And also, yes, when you are buying one Unacademy, not only getting my courses, you are getting educate all the educators courses who are teaching under this category. Okay, yes, all the subjects you are getting along with the general aptitude. And right now there is a new you know feature on Unacademy Plus, which is Ask a Doubt. Okay, so this Ask a Doubt feature is going to be applicable for both the aptitude questions as well as your CSIR NET Chemical Science questions as well. So in this photo, and you will get the written solution or a video solution for it. Okay, yes, so this is a new feature which has been added to Unacademy, right? Okay, now also for all of you, what are the free classes, what are the YouTube sessions for the month of November? So we are going to have various important concept sessions, okay, at 9 p.m. Okay, so note down the timing, guys. For November, you are having Thursday, Friday, 9 p.m. Okay, yes. Good evening, all of you. Good evening, welcome. Okay, and every day in the morning, 10 a.m., we are already doing a lot of practice of a lot of concepts in this month. Organometallic, bioinorganic, and spectroscopy is going on in the Battle of Poles. So if you haven't yet joined, please do. These are all free sessions. Okay. Yes. So let's now move onwards, guys, and let's quickly start our discussion. So what are we going to talk about in today's session? Okay, let's see that. Agostic and Anagostic interactions. Okay, I hope once again that all of you can see and hear me properly because we're going to start our discussion. Right, and the thing is, the most important thing is anagostic and agostic interactions. Why do we study them? We study them because we want to explain some reactions, and some particular type of interactions, right? So that is why we want to study these agostic and anagostic interaction. Okay. Yeah, good evening once again. So let's first talk about which reaction we want to understand based on the agostic and anagostic interaction. So first thing first, guys, I hope that all of you have a little idea about the oxidative addition and reductive elimination. Yes or no? Oxidative addition reaction and reductive elimination reaction. Yes. So that is what we have to talk about. And this reaction, particularly for a specific kind of a molecule, is going to have the agostic interaction. And we are going to then talk about these interactions in detail. ठीक है? तो अगर हम बात करें about any random metal, let's say this is your metal complex, okay, where the metal is there in the zero oxidation state, for example, plus X and Y. So this component, right, it is going to add to the metal separately as ligands like this, and the metal oxidation state now becomes +2. Okay, so oxidative addition is when the metal becomes, when we are starting, for example, with a 16 electron species, okay, when you're adding some ligand to it, and then it is becoming the 18 electron species with losing 2 electrons from the metal. So the oxidation state of the metal is going to increase, right? So these are some really important points which we need to discuss about oxidative addition. First thing is that there must be some non-bonding electron density on the metal. So there must be some non the metal, which means the metal must be electron rich. Okay, which means the metal must be electron rich, right? Secondly, it should also be coordinatively unsaturated. All right, what does that mean? That means that the metal that you want to do oxidative addition on, it must have space for two ligands to be added. So usually coordinatively unsaturated means either the coordination number is 4, coordination number is 4, either the complex is tetrahedral or it is square planar. Okay, in these two situations it's going to be the best. Okay, good evening guys. Also, a metal must be stable, in the higher oxidation state, right? A metal must be stable in the higher oxidation state. For example, if you're talking about, let's say, iridium, we are doing the oxidative addition. Iridium is +1, goes to iridium +1. What is the number of electron that it has? And iridium +3, what is the number of electron that iridium +3 has? So basically, iridium has a total of 9 electrons. So this is going to be a D8 square planar system. All right, diamagnetic in nature. Okay. And iridium 3 plus is going to be D6 octahedral. Once again diamagnetic, because it is going to be, the splitting is going to be like this, that is octahedral D6 low spin always. So all the electrons are paired up. And D8 square planar is going to be in this way. This is your D8 square planar system. All right. So yes, metal should be stable in the higher oxidation state after the oxidative addition, then only this. Now why are we talking about all of these details? Because we have to see the type of mechanism before we consider the agostic and the anagostic interaction, right? So yes, so if I ask you using three reactions, let's say this is your popular Vasca's complex that I am drawing over here. Okay, so this is your popular Vasca's complex. All right. So in the presence of Cl2, yes, in the presence of Cl2, we see that the Cl2 which is added to the molecule is added in a cis manner. Okay. Let's say this is Cl dash that we are adding just to differentiate. Obviously, there is nothing like Cl dash, but just to differentiate. All right. So now if you add an if you add an oxygen molecule, for example, over here. So I am adding three different types of molecules. Let's see what are the three different products for the oxidative addition. Lastly, if I'm adding the methyl iodide to the Vasca's complex. Okay, this is what I get. Yes. All right. So basically, guys, what is happening in the oxidative addition? All of these are oxidative addition reactions, right? But the molecules which are added are different. Why? Because first of all, if I say that I have added methyl iodide, okay, if I say I've added methyl iodide, now this is a polar molecule. Polar molecule always adds in a trans manner. Yes. So polar molecules are going to add in a trans manner. फिर आया non-polar molecule like chlorine or any other molecule like methane or anybody else which is a non-polar molecule like chlorine. This is going to add in a cis manner always. Okay. The process that we call trans, when we get a trans molecule, the process we call it is SN2 like mechanism. Here it's going to be a concerted one. And here, see, we have added a molecule with a pi bond. So it's not only just one single bond which is breaking down, it is a pi bond, and the molecule definitely it has to be cis. But this is also oxidative addition because first iridium was +1 and here iridium is +3 because now the oxygen have become peroxide. This is -1 and this is also -1. So iridium is going to be +3. All right, so this is what we get from here. Now, moving onwards and seeing that what kind of interactions we want. Okay, what is the type of interaction that we want? What is the type of reaction that we are defining? Okay. So the final product is something like this. All right, this is PPH3, this is PPH2, this is once again triphenyl phosphine. Okay, so this is the final product that you get. Okay, what kind of a reaction is this? Is it also oxidative addition? That is what we are talking about. And that is why we require to understand the agostic and the anagostic interactions. Okay? Yes. So this is also, I would say, intramolecular. Yeah, roughly we can call it intramolecular oxidative addition, right? Roughly we can call it intramolecular molecular oxidative addition, but let's see what's going on. And for understanding this thing, we have to understand a lot of things, guys. Ki what is happening around. So iridium is somehow interacting with this hydrogen, which is there in close proximity through a benzene ring, right? And that is the iridium doing oxidative addition in between the CH bond. So this is carbon, this is hydrogen, right? If it is doing oxidative addition in between the CH bond, they are supposed to add syn to each other, or they are supposed to add cis to each other. So this is the new carbon bond and this is the new hydrogen bond. They have to be cis. And as you can see, this is your new carbon bond and this is your hydrogen bond over here. Right. So let's now talk about what is going on. What are these type of interactions? Okay. So let's define this interaction. The agostic interaction. All right. So agostic, what does that mean? Agostic means to hold on. Okay, to hold on to something, right? That is what is the meaning of agostic interaction. Also, we have different types of agostic interaction. We call them alpha, beta, gamma, and delta also sometimes. Okay, we call them alpha, beta, gamma, and delta agostic interactions. But yeah, how do we know which is which, right? Yes, what is basically the purpose of studying the agostic interaction? Because we want to see the CH activation. Okay, intramolecular CH activation due to chelation or let's say close proximity with the metal, that is your agostic interaction. So, what is an agostic interaction, guys? Let's say there is a carbon which is having a hydrogen. Now, this is attracted to the metal. Okay, this is attracted to the metal. Now, what is the type of interaction? Agostic interaction is a three-centered two-electron bond. Please remember, agostic interaction is a three-centered two-electron bond. Okay. And what are the different characteristics? The bond length of the hydrogen and the metal. It has to lie in between 1.8 to 2.3 angstrom. Okay. And along with that, the angle, the CH, the CH and metal angle which it makes is 90 to 140 degree. All right. So this is the criteria of having a agostic interaction. 1.8 to 2.3 angstrom or 18 to 23 nanometer, and the bond angle has to be like this. And this is a three centered two electron bond. Okay. Now there is one more thing when you talk about the proton NMR activity of this hydrogen. right? ये जो hydrogen होता है, since it is having a agostic interaction, the value, the ppm value, okay, which means that the value of the hydrogen is going to go upfield. Let's say if your normal CH bond is like a 1.3 or 1.5, something like that, then this hydrogen is going to be really upfield. It's going to go zero, or it's going to go minus, something like that. So this hydrogen is going to be upfield with respect to your normal hydrogen or proton. Okay. However, you also are going to see one more type of interaction, that is anagostic interaction. So what is that? What is an as some different properties, might look like that your hydrogen, similar situation when a hydrogen is attracted by a metal. Yes, it could be possible, but look at this. When your proton is having a distance of 2.3 to 2.8 angstrom, 2.3 to 2.8 angstrom, then it is your anagostic interaction, all right, and the bond angle is higher over here, 110 to 170 degrees, all right. 110 to 170 degrees, this is your bond angle that you are getting. Okay, so also the proton nmr value, for this, the delta ppm value for this hydrogen is going to be downfield to free ch. What does that mean? That means a whole lot of difference. That is, here in the agostic interaction, the hydrogen is shielded, it is very electron rich. However, in the anagostic, yeah, in the anagostic interaction, the hydrogen is de-shielded, and that is why it is going downfield to the ch. Okay, that is the thing. Now, what are the other properties and how many examples do we see? Also, there is one more thing. This, okay, so there is one more thing, center to electron bond, all right, and it is a electrostatic interaction, just like that happens in between an electron rich metal and the electron deficient proton. Okay, so this is nothing, just uh you know just an interaction between the electron deficient hydrogen and your electron rich metal. This is not a three center to electron bond. Okay, so these are the major differences between the agostic interaction and the anagostic interaction. Now let's look at some examples for these. Okay, so let's talk about beta beta agostic interaction. Yes, let's talk about the beta agostic interaction. So let's say we have a complex like this. Okay, So this is your very simple complex, right? And questions come on these kind of complexes like this, that why are they unstable? They are unstable because anytime they can undergo beta hydride elimination. Why do they undergo? Let's see. Okay, so this is what you have. All right. So sometimes we mention that why are we having beta hydride elimination? Because we have the beta agostic interaction over here. What is beta? See, here you have one carbon connected to titanium. Okay, we call this carbon the alpha carbon. This carbon we call the alpha carbon. This carbon we call the beta carbon. So the hydrogen is connected to the beta carbon, and that is why we call it beta agostic. Okay, how do we know it is agostic interaction? Because after doing the interaction, right, after doing the interaction, it has become a hydride donor. Okay, so it has become a hydride donor ligand in itself, right? So that is how we know that this is a beta agostic interaction. Why? Because the hydrogen is shielded. It is up, okay? It will be upfield when it is electron rich, isn't it? And when it is becoming a hydride donor ligand, then it will be upfield. Okay? Yes, right. Now we move onwards. Okay, let's also see that the titanium and the hydrogen bond length over here is 2.06 angstrom. Okay, the angle, whose angle? The carbon, the hydrogen, and the titanium. The bond angle is 90.4 degree, exactly in the same range that we had talked about previously. ये देखो 1.8 से 2.3, right? So this is the range 90 से लेकर 140 degree. This is the range for the agostic interaction. So this is in the range both of these data. Yes, and right, this is going to be your agostic interaction further confirmed by the experimental values. Okay. Yes, so here we are using the beta agostic interaction to define the beta hydride elimination process. Okay, chalo. We move onwards to next example, and we also see, let's say we are talking about, all right. So let's say we are talking about a complex having coordination number 5, like this one. Now what will happen? The tungsten might interact, all right, the tungsten might interact by one of the cyclohexyl hydrogens, isn't it? It might interact with one of the cyclohexyl hydrogens to which is connected to the phosphine, right? So how many number of atoms are involved? Phosphorus is the alpha unit, the alpha atom, then this is beta, then this is gamma. So you call it gamma agostic interaction. Okay, you call this gamma agostic interaction, right? And once again, if we check the angles and the bond length, let's say the metal hydrogen, the tungsten hydrogen bond length is 2.27 angstrom. Now this is much longer than your beta agostic interaction, because isn't it obvious, beta carbons are closer, gamma carbons are farther away. So it has to be a little bit larger, lekin it is still in the range of the agostic interaction. And the angle that is makes the MHC bond angle, it is 127.6 degrees. Okay, so this is the bond angle once again. So yes, it falls into the gamma agostic interaction. All right, so let's also look at the anagostic ones. So in this complex, see, you are not supposed to remember all these examples, just to understand what is the agostic and the anagostic interaction. See over here. So what happens is, this is an anagostic interaction. How do we know? Because platinum metal, the platinum hydrogen bond length is 2.54 angstrom, which is much higher than 2.3 angstrom, which was the limit. It was the upper limit for the agostic interaction. So this is an anagostic interaction by the experimental methods that we have found out. Also, if you see the platinum hydrogen carbon bond angle, it is 143, very much higher, right? And it is also found that the proton NMR value for your for your hydrogen, which is connected to this carbon, for your CH, basically the hydrogen, the proton over here, that is 10.97, which means it is highly deshielded, isn't it? It is highly deshielded, 10.797 ppm. So this proton, it is a highly deshielded proton. It cannot be doing a agostic interaction, because agostic interaction gave you a shielded proton, right? तो इसे अगर ये deshielded है तो definitely ये क्या है, anagostic interaction है. And this is also not a three center to electron bond, it is just electrostatic. How do we find out all these values? ये कहाँ से हमें पता चलता है guys? ये पता चलता है X-ray diffraction studies से, okay? Or X-ray crystallography. From there you get to know the bond angles and some bond length, okay? Right. So we are just doing one example of the anagostic interaction. और अब हम क्या देखेंगे guys, ये बहुत important जो हमारा question था, we will go back to that question, right? And we will see why did we want to study these interactions. Okay, so refluxing the same Vasca's complex, I have just removed the carbonyl over here. There are three phosphines and one chlorine over here. So refluxing this in 1 hour in benzene, all right, refluxing this for 1 hour in benzene is going to lead to orthometallation, all right. And what does it give? So guys, can you tell me what is the agostic interaction, alpha, beta, or gamma? Obviously, the beta and gamma and agostic interactions are the one which are the most frequently seen, okay, because of their perfect distances. But can you tell me what is this interaction that is leading to this reaction? Okay, the beta agostic or the gamma agostic. So this is your alpha phosphorus, this one is beta, this one is your gamma carbon. So it is a gamma agostic interaction. It is a gamma agostic interaction which is taking place so that here your iridium complex is a +1 species. Here it is 16 electron species. Now here it becomes iridium +3. It becomes a 18 electron species. So this is nothing else but a oxidative addition reaction. This is nothing else but an oxidative addition reaction, but it is a little bit different from what you have already seen. It is a intramolecular reaction leading to orthometallation. All right, this is your final product. Okay, now you might end up over here, or you might also get reductive elimination from this compound. That is, reductive elimination only happens for the cis elements, that is for the groups which are cis to each other. Who is cis to each other now? Hydrogen and a Cl. They are cis, so minus HCl we have got, and the final product is going to be iridium PPH3. Alright, it's going to be a square planar complex like this. Okay, so now this is once again a 16 electron complex, a square planar one, right? And this is what you have got finally from the oxidative addition using the agostic interaction. So this was a very common compound, okay, orthometallation involving the phosphine group of this complex, right? The complex is IR PPH3 whole thrice Cl. 16 electron species, very similar to your Vasca's complex, right? So you have used the gamma agostic interaction to identify the product of the oxidative addition reaction. Okay, yes. So this is one type of reaction which is very, very important, which has been used, which has been described through the agostic and the anagostic interaction. Okay, I hope it makes sense to all of you. Okay, so we'll be doing another example of a similar compound, of a similar uh, reaction. You see that there is a rhodium over here, connected like this. Okay, all right, just a second. there's the rhodium over here, RH, another RH, like this. Okay, so now if we are refluxing this complex with your rhodium is there in the +1 oxidation state, and this is a 14 electron species because it is a square planar, right? And also few ligands over here. Now if we are complexing this with, let's say, this molecule, tertiary butyl whole twice. Now this is a bulky one. Okay, right. So this is what we have, right? ये हो गया हमारा एक phosphine diphosphine ligand. But is the rhodium only going to be complexing with the bisphosphine, or is it also going to interact with somebody else? So usually तो क्या होना चाहिए? This is a bisphosphine ligand, so it is just supposed to lose the chlorines and just get attached to the phosphorus. But let's see what else is happening. इसका जो product बनता है, okay, there's a methoxy here, here and here. The methoxys are not changing. Okay, so the product that we are supposing that should be is your tertiary butyl whole twice groups. ठीक है, फिर एक rhodium, फिर एक और tertiary butyl whole twice connected to the rhodium once again, but the rhodium is having one Cl and it is having one hydrogen and one carbon ruthenium bond. ठीक है, so what is extra? These two bonds are extra, and these two bonds have come through agostic interaction. They have formed through agostic interaction. कैसे पता चला? और ये हो क्या रहा है basically, guys? Okay, just a second. This is rhodium. This is not ruthenium. Yes. So what is happening basically? Rhodium ने किया है transmetallation, ligand exchange किया है rhodium ने basically. So rhodium, when it does ligand exchange, so it is only supposed to connect to this phosphine through the lone pairs, right? Lekin along with doing that, right, rhodium has disconnected from itself. It has got just one क्लोरीन विथ इटसेल्फ, राइट? दो फॉस्फीन हो गए इस तरीके से. लेकिन इसने क्या किया, एक जो कार्बन हाइड्रोजन बॉन्ड है, दिस कार्बन हाइड्रोजन बॉन्ड, इट इज एक्टिवेटेड एंड इट हैज अंडरगॉन ऑक्सीडेटिव एडिशन. ठीक है, फिर से ऑक्सीडेटिव एडिशन हो गया यहाँ पे. ओके, इन द CH bond along with ligand exchange तो है ही, राइट? लिगेंड एक्सचेंज तो हो ही रहा है, बट उसके साथ ही साथ में यहाँ CH एक्टिवेशन करके ये भी हो गया है रिएक्शन. सो व्हाट इज द टाइप of interaction once again if we want to understand? Okay, so this was the type of interaction which was taking place. ये क्या है? Alpha, beta, gamma and delta. Okay, so alpha, beta, gamma and delta. This is your delta agostic interaction, which is actually not very popular. ये इतना ज़्यादा popular नहीं होता है, but because the rhodium is falling in close proximity with this benzene. Why? Because दोनों phosphorus जो है, those two phosphorus are bringing the rhodium together. टू दिस हाइड्रोजन। इसकी वजह से ये यहाँ पे इसके साथ में बॉन्डिंग कर पाया है, एंड that is called the delta agostic interaction over here, which is leading to a new bond, CH activation and oxidative addition of rhodium in the CH activation bond, right? So guys, I have given you some really good examples of the agostic and the anagostic interaction. ठीक है, आप चाहो तो ये बुक से भी फॉलो कर सकते हो, बहुत अच्छे एग्जाम्पल्स है ये. What are you supposed to remember? You are just supposed to remember that you might see a beta agostic interaction. Okay, the most popular ones are beta, gamma, and delta. These three agostic interactions are most popular. Okay, all right, guys. So yes, let's wind up. And we have studied the oxidative addition and agostic and anagostic interaction, जो कि इसका एक application है. Right, and in the upcoming session, as you can see कि एक session already हो चुका है. In the upcoming session, if you want me to take a particular topic, then you can message me on Telegram, and also you can tell me in the live class that what is the topic that you want to study. All right, for the organometallic, क्योंकि organometallics की already जो series है that is going on already, right? 10 a.m. daily we are doing. तो जो भी concept है, we are going to have a session tomorrow, 12th of November, same time, 9 p.m. Okay, we are going to have a session tomorrow. So tomorrow you can tell me which concept you want to study for in this session. Okay, we have done the agostic and anagostic interaction, and that was also a request from the student. तो इसीलिए आप कुछ भी अगर आपको नहीं समझ में आ रहा है तो we can discuss in these sessions, right? All right, guys. So yes, once again reminding you of Unacademy Plus if you already haven't, और यहाँ से आप सारे course pages और profile check कर सकते हो. Okay, and I will see you soon tomorrow, 9 p.m. same time. So have a good night, everyone. Bye, guys. I'll see you very soon.